All right, so let's answer this final question here. So this is part C. It says, what's the probability that she runs exactly twice in the next 3 days? So she needs to run exactly twice in the next 3 days. Now, this is where you've got to remember that we know that she runs the first day. That is what we're told here. Suppose that Rachel runs 1 day. So she's running this first day here. Therefore, the next 3 days would be what? Well, this would be the next day. This would be the day after that. So the second day. And then the third day is this. So as you can see, day 1, day 2, day 3. And we want to figure out that she runs exactly twice in the next 3 days. Okay, now we just have to kind of look at this and figure out which percentages we care about, because I really don't want to fill out all the percentages here, otherwise I will just be here forever. So the probability that she runs in the next 3 days would be this branch, and then this branch, because it has to be exactly 3 days. So I can't include this branch here, because then she'll be running 3 days. 2 days of running, 1 day of not running. Or it could be this branch. Run, not run, run. Or it could be this branch, not run, run, run. But that's it. There are no other days in which you're running exactly twice. So now I can just figure out the probabilities of these branches here. Now remember, if she runs and then runs again, there's a 4 in 5 chance. So this one also will be 4 in 5 chance. Now, the probability that she doesn't run, given that she's run the day before, what's that probability going to be? It's going to be 1 on 5. And let me just try to make this 1 on 5. The probability that she doesn't run, given that she's run the day before, is, you guessed it, 1 on 5. The probability that she runs, given that she didn't run the day before, is going to be what? The probability that she runs is going to be 1 on 4. So this is where you've got to be able to look back at the examples that you were given here, or the statements here. The probability that she runs the next day, given that she didn't run the day before, was 3 on 4. So therefore, I was able to figure out that it's going to be 1 on 4 there. So just a bit of thinking through there. If you want to, you could fill out the entire thing, but you'd be there for quite some time. Okay, this one will be 1 on 5. The probability that she runs, given that she didn't run the day before, will be 1 on 4. And the probability that she runs, given that she'd run the day before, will be 4 on 5. So now we can figure out the probabilities of each of these. So we can figure out, okay, what's the probability that she runs, then doesn't run? That's going to be 4 on 5 times 4 on 5 times 1 on 5. What's the probability that she runs, doesn't run, then runs? That's going to be 4 on 5 times 1 on 5 times 1 on 4. Then what's the probability that she doesn't run, runs, and then runs? That's going to be 1 on 5 times 1 on 4 times 4 on 5. That's all looking good. Now, I'm far too lazy to do that by hand, but that is why we can now use our trusty CAS calculator. Okay, so the first one is, and remember, you can go control divide to make that a bit easier for yourself, 4 on 5, and then we're going to multiply that by 4 on 5, then we're going to multiply that by 1 on 5. Hopefully you can do this a bit quicker. I'm a bit slower doing it on the computer. Okay, that looks good. There it is. And then I might cheat a bit. I might just bring this down and then make some alterations. This is now 1. That is now 4. Then I'm going to cheat again. I'm going to bring this one up. This is now 1. This is now 4. This is now 5. And this is 4. That's all of that. Now I'm going to add them all together. So I'm going to take that. I'm going to, whoopsie daisy. I'm going to add it to that. I'm going to add it to that. I'm going to get that. Now the back of the book has it as a decimal. So let me just take this. Let me go control enter. I'm going to get 0.208. So add all together. I'm having a dumb moment right now. Is all together one word? No. All together? I can't remember. That's right. This is an English class, everyone. 0.208. That's the answer. But if you want to stay with me for a second, altogether is one word, isn't it? Is it? Altogether one word? I'm Googling it. Altogether one word. The phrase altogether, two words, refers to people or things gathered in one place. The adverb altogether means entirely whole. I have no idea, people. It doesn't matter. That is really beside the point. If you made it this long into the video, you can come find me and say, did you figure out your problem with the word altogether or not? And I can say, no, I really don't understand what it is. Here, let me copy the definition here. This is the definition of altogether. So there is, sometimes it's used for two words, sometimes it's one word. I don't know. I really can't be bothered putting in the brain energy to read this properly. But there you go. There's your answer. Hopefully you enjoyed my little rant there about English. Math is so much better. All right. I'll see you later.